Good afternoon, my dear learners. So, today the next topic is supervised learning classification algorithms, right? So, classification algorithms, the name itself, we can understand that it is going to do some classification. What kind of classification it is? So, myself, Johnny Sebastian, from the Department of Computer Science and Engineering, from Hindustan Institute of Technology, Coimbatore. Once again, I welcome you all to learn today's section. Got? So the first algorithms we are going to see is k nearest neighbor, then decision trees, random forest, right? So this is what the thing we are going to do. So first question I want to ask, what do you mean by, what do you know about supervised learning techniques? So as we know, some learning techniques, the machine learning is going to learn many things with the help of data set, right? We're going to train the model with the help of the data set. We need to give a lot of inputs with the help of using the data set, right? So not only with the data set it is going to learn, with the help of some methodology like these kind of algorithms, the machine learning model will learn a lot, right? So the first thing, the basic first algorithm is k nearest neighbor. The short form is KNN. KNN. KNN algorithm is a very familiar technique, but it is actually, my friends, this is very basic technique. This will not be very useful in a very complex area or complex predictions, but it is a very first step in supervised learning, right? So next two I'll explain you later. So k nearest neighbors. So nearest neighbors means here the similarity in terms of behavior. The similarity in terms of behavior, right? So similarity in terms of behavior only it is telling. So what do you mean with similarity? I want to ask you, my distinct colleagues. So similarity, for example, how can I tell you a real time example? Say for example, we are using Amazon, Flipkart, Netflix. Okay, so these kind of recommendation method systems, right? So these are all recommendation systems. What is that? So this k nearest neighbor is a perfect algorithm for the, or the first initial step algorithm for the these kind of recommendation systems. So you must know what is recommendation systems, right? So we day to day we are using Amazon, Flipkart, kind of some applications in our mobile, right? For example, we use Amazon to purchase a Bluetooth speaker, right? I'm interested to purchase a Bluetooth speaker now. I'm searching, for example, a so and so company, for example, boat, stone, something. I'm searching. My interest, the amount range is about 2000 rupees, 1500 to 2000 rupees. I'm exactly searching for a one product name with the same ID, product ID, everything. Even though it will suggest a lot, a similar product. This is nothing but the similarity, right? This is but nothing but the similarity. How it is achieving from user to user. This is a recommendation system success. Actually, the k nearest neighbor. So before explaining the algorithm, I want to help you with this diagrammatic, right, representation. So look at this diagram. Here, green color and sunlight image is there. No, there are two sections. Here we are classifying two things. This is A, this is class B. Green is class A, then yellow is class B. I'm labeling now, right? So one new element is coming or one new user is coming. So that new thing should be labeled either either in A class or in B class. It should be in one class only. Am I correct? So how k nearest neighbor will do? K means what? We need to assign some random value. Okay, it should be more than 1, right? It should be more than 1. Why? Because more than 1. For example, if you assign 1, which one you will take? Actually, this algorithm, how it will work, the new element will come, right? This ash like image will come. For example, I am assigning 5, k is equal to 5. So the nearest to the new element, I need to what? I need to check nearest 5 elements to the new element. Am I clear? Am I understandable? Okay. So the thing is, a new element is coming. I assign k is equal to 5. So 5 nearest element of the new element should be identified. Whichever is majority, okay, I should assign the new element to that side. For example, here k is equal to 4. The red circle only takes 4 element, but unfortunately green to yellow too. So how I can fix the majority? There is no majority. So equal 50-50. So for this, what is the recommendation? What is the suggestion? We need to go for odd number. Don't go for 1, more than 1, maybe 3, maybe 5, maybe 7. Okay. So in the next step, what we have done in the blue circle, it is, I think, it is 11. Okay. 3, 5, 7, 11. Okay. 11. It is 11. So there is odd number, there is a more sample. So we can fix either it is a one side. So here majority is green color, the new element is in the green color. So understood? So how we can relate this in a real-time example? You are searching for boat Bluetooth speaker. It is a range around 1500 to 2000, right? So in the world, n number of customers have searched similar to that, not exactly same, similar to your criteria. Definitely will match your what idea, thought. So they are your neighbors, right? They are your neighbors. What are all the interests they have searched? That will be suggested to you. Got it? This is nothing but recommendation system. So this is what the k nearest neighbor is doing. So first, the steps of the algorithm is what? You need to assign a random value to k. Okay, it should be an odd number. Why I am saying it should be? Then only you will get a more than 50%, right? If you assign a even number, definitely there is a probability of getting 50-50. So to avoid that, use odd number. Understand, this is a recommendation, not compulsory, right? If you use even number, maybe you can get the majority, right? Okay, then second is what? You should calculate the distance between the new data and the existing data, so that after that you arrange in the ascending order. Then the third step, nearest neighbors, right, to the new entry, to the new element, based on the distance. Probably it is Euclidean distance, right? Other distance is not there, Manhattan distance is there. So most frequently used distance measuring thing is Euclidean distance. So now we have found many nearest points or data points or similar users in real time, I say. Then finally you assign that new data entry to the majority as the nearest neighbor. As the nearest neighbor. Okay, you got it? So k nearest neighbor is this only. This is a very basic only. You can't use this for a much complex relationships. That is, you can't use this for a very tedious process, right? So recommendation systems. So that in that also you can use for very initial level only. So as we have discussed, so we need to see some problem statements, right? So some of the basic problem statements, as I said, you look at the second one, create the lecture video recommendation system using KNN. Yeah, it is possible using the K nearest neighbor. Also, what are all the other problem statements or the examples, real-time examples? So predict the price of a stock, predict the price of a stock on the basis of a company performance measures and economic data. See, this KNN will find the similarity between the users. Based on the similarity, it will form one group. So to that group, the suggestions will be recommended, right? Suggestions will be recommended. So I hope you all understood the K nearest neighbor concept. So the random forest decision tree will be taken in the future classes. Thank you. Thank you very much. So, in the last class, we have seen the KNN in machine learning tutorial. So now we need to see some quiz in this topic, right? So usually you will do right. So similarly today's topic. Okay, go for it. Try. Right. So what is KNN means for? The full form of KNN. KNN full form. Yeah, very good. You are correct. Yes. K nearest neighbor, right? Then, which of the following is the key characteristics of KNN? Recall the topic, right? Recall the topic. Which of the following key characteristics? That is very important. That is a key characteristic. So what is the first one? Requires labeled training data, reduces dimensionality of data, reduces, yeah, this is the first one. Yes, correct. So the next one is, does KNN classify a new data point by voting? It will go by voting or something else. K nearest neighbor will select the nearest point, that is a new data entry, new data point. How it will be assigned? Yes, correct. Voting. So what is the primary parameter which influences KNN's performance? KNN's performance. Yes, correct. The final question is, what is the distance metric frequently used in KNN? Manhattan distance, Hamming distance, cosine similarity method, Euclidean distance. Which is the frequently or most commonly used, conventionally used distance metric? Yes, correct. No, not Manhattan distance, Euclidean distance. Right? Good, good, good. Thank you, thank you, thank you, thank you for the, thank you.